I have a video on acetal and ketal chemistry, and I've suggested it's important to remember the mechanism of ring formation and ring opening of acetals and ketals via hemiacetals and hemiketals. But I didn't really say why it was so important. Now I'm getting to the crux of the matter here. That aldehyde acetal ketone ketal equilibrium is really important in carbohydrate chemistry. It's important because different structures of carbohydrates are in equilibrium often. So just to go over the series again, aldehyde, hydrate of an aldehyde, hemiacetal, and acetal. We learned all that in the last video. Similarly, ketone, ketone hydrate, hemiketal, and ketal. So look at this structure of glucose here. Do you see an acetal, a hemiacetal, or an aldehyde? On the left, I see a hemiacetal in the cyclized form. But in the trace of a little bit of acid, then that can open in equilibrium to an alcohol and an aldehyde. And then it can close in an equilibrium. But when it closes, what used to be an alpha anomer can convert to a beta anomer, and vice versa. So the optical rotation of glucopyranones in the presence of a little bit of acid can drift as the equilibrium changes, maybe with a slight change of temperature. But that's not all. When the glucopyranose, or in this case, fructose, opens, say it opens from the furanoside form, it can open to a ketone and an OH, and then use a different OH to cyclize again to the pyranoside form. So you have quite a messy solution here. You have, for glucose, for instance, you have the pyranose form, the furanose form, and the alpha and the beta anomer all equilibrating if you give them a chance, a little bit of acid. The challenge for a chemist is, can you draw the stereochemistries of all these and keep them correct as you draw the furanose, the pyranose forms, and the alpha beta anomers? Thank you for listening. I hope this helps with your studies. Bye bye.